Hey yo, what's up? What's good? Thanks for coming by the stream. It's good to see you again. Oh, camera's right here. I have another screen off to the side, so it's hard for me to look at the camera because it's very tempting to look at myself in the screen to make sure everything's good. But I'm gonna have to adjust where my camera is at some point. Anyways, thanks for coming by. We're about to start coding, and I'm going to pick up where I left off in the last live stream. And if you weren't there, what we're working on right now is we're working on a visualizer tool that helps us to see what a linked list looks like. So this is kind of a data structure visualizer, and this is going to be something that works inside of the terminal. And so I can show you an example. I'll just do it here. So when this is, well, this is pretty much done, but I have to do the main implementation. But when we run this in the terminal, we'll see something like this. So basically, whenever you're working on a linked list is a data structure that allows you to have nodes, and these nodes point to the next node. And it's a really important data structure because it allows you to store a lot of data without having to have it in the same place, in the same, they don't have to be like in adjacent blocks of memory necessarily. And yeah, linked list is just really important. It's also really important for things like, for like what's it called? Like crypto, like the underlying blockchain. That can be like thought of as a type of linked list as well, where you have many nodes, and those nodes have references to their next node in the collection. So so yeah, we're just doing a linked list, and that part is already done. The simple implementation is already done here. Real simple here. The way that this works is at the beginning, when this is first created, a new simple linked list is made, and it is an empty struct. And what we do is we can insert the first thing. When we make this first insertion, it will go and look and see if the head is nil. If the head is nil, then we're going to make this new node the head. And if it's not nil, then we're going to make the new node point to the head, and it's going to become the head. So that's how we can get this little chain here, basically. So that is pretty much done. There are more complicated ways to do this, but the main feature that makes it a linked list is that it contains at least one pointer and one value. Out of a bagel, by the way. Okay, so mhm. Okay, so where were we? We finished the visualizer. The visualizer allows us to see something in our terminal. Um, so if we go to our visualizer test here, you can see here this is what we're testing for, and that test is passing. Okay, so now that that's working, what we can do is we can implement a new type of linked list in this. And we're going to do a doubly linked list. So we have to do the test for that, the implementation for that, and then we also need to make sure that the visualizer is extended to work for that as well. So we're going to start with the test. So pointer to testing.t. And then we're going to say this list is going to be a new doubly linked list. We have not made this method yet, but we'll say if list is nil, then we need to throw an error. That error will say new doubly linked list should not return nil. And if list.head is not nil, because when we make it, it won't have a head, then we'll say list should not, or it should have nil head. And then we'll say if list.tail is not nil, then we'll say t.error new list should have nil tail. So you're probably wondering, if you're watching this, like, what is a doubly linked list? I think that Claude might be best at explaining it. So let's just check out what Claude has to say. So give a simple explanation of what a doubly linked list is. Explain as if you were a mentor talking to me. Okay, so we can actually have Speechify read this for us. It'd be kind of nice for you all, I guess. So we'll get Speechify going on here. It's always kind of weird getting Speechify to work in Claude because I've learned that it doesn't work with streamed text at all. So we have to wait till it's already on the DOM. So let's start right here.
Here's a standard.gitignore file for Go projects.
Nope.
Certainly.
Let's start here.
Imagine you're in a line of people, and each person is holding hands with the person in front of them and behind them. That's essentially what a doubly linked list is like in computer science. In a doubly linked list, each element, we call them nodes, contains three things: the actual data we want to store, a link to the next node in the list, a link to the previous node in the list. So, unlike a simple linked list where each node only knows about the next one, in a doubly linked list, each node knows about both its neighbors, the one before it and the one after it. Let's visualize it. Copy null LTGT, data 1 LT. Here, each data box represents a node. The arrows LTGT represent the links between nodes. Notice how they go both ways, and the list starts and ends with null. The benefits of this structure are: you can traverse the list in both directions, forward and backward. It's easier to insert or remove nodes because you have direct access to both neighboring nodes. However, the trade-off is that doubly linked lists use more memory because each node needs to store an extra link. Think of it like a train where each car can connect to and disconnect from its neighbors easily, and you can walk through the train in either direction. Does this help you understand the concept? Do you have any questions about how doubly linked lists work or how they might be used? Claude does not have the ability to run the code it generates yet.
We're going to have Claude make an SVG diagram. Oh, excuse me. Oh, I'm dying. So we're going to have Claude make an SVG diagram that's going to explain. We'll see how this turns out. I might include this in the repo. Okay. Okay, I see what this is saying. So I think this is fine. This top arrow is kind of bothering me. Let's see. The head and the tail should point to null, but not have any pointers. Let's see if we can edit that. I might come back later on and just do a bunch of these and then include them in the repo because that'll be helpful for me and other people as well. So the arrows need to point towards the nulls. Because the thing is that there's nothing that is pointing to the head, and there's nothing that's pointing to the tail. But the head and the tail will both have they'll both have um, a value that's supposed to point to next and previous. The tails, the head's previous needs to be pointing to null, and the tail's next needs to point to um, to null. Okay. So this is pretty good. We'll just have it, we'll just pop these images in here. And then I'll say, please now make one for the simple linked list. What else? Because I'm going to do doubly linked list, simple linked list. We're going to also do a circular linked list as well. I'm going to have to do the graphic for the circular linked list later on because I forget what that actually is. The problem with this one is that the pointer does not point to null. It has a next value that is just nil. At the end of the linked list should point to nil, not null. Okay. I don't think I actually know what the difference between null and nil is, but I know that that is what it shows up as when I run the code. Maybe we'll ask that too. Okay, so singly linked list. We'll just say simple. And we'll say this one is called doubly linked list. Okay. And we'll just put these in the images folder, which we have not made yet. And we'll save those. Oops, we'll save those for later when we do the README. Because I'm probably gonna pop these into Freeform and make like a really nice PDF of sorts. So then that way, like you could actually download this and have the high resolution, high quality version. Um, okay, we'll remove that, and we're gonna move that. Thank you, babes. Okay, so that helps. I do remember this. Actually, I worked on another repo a while back. It was the GoLang linked list practice, and there's actually a OpenPair video that I did in my channel. And this talked about the linked list. It also has a diagram for the reversal algorithm, or if we wanted to reverse the order of the linked list, how that would work. Um, if you go look for the, or here, I'll just actually show you what that is here. Give me 1 second. I'll show you the repo so you can go and check it out. So, I did this like last winter. And okay, so if you go to my GitHub, you'll see that there's this repo, OpenPair GoLang linked list practice. Okay, if you don't know how to get to this repo and you want to like look at this, then you can go to my YouTube channel and you can see that I have this one called OpenPair GoLang, and it's these most recent 2 videos. Okay, so they're just me practicing. Um, if you're curious to know more about linked lists, and then I think, let's see here. Yeah, it's just those 2 videos. I had started out wanting to do like a little tutorial style explanation. I never got around to it, but I think I'll do that at some point here pretty soon. Okay, so anyways, if you want to see that video, it'll basically explain and show you how I did all of this right here. And this is a great resource. So, okay. So let's go back to our code and we can get to coding now. There we go. Okay. So um, we have our test. We're gonna have to do a test for insert as well. But we're gonna wait to do that. We're just gonna do the implementation for the single linked list or for the doubly linked list first. Um, um, Now, do I want to do all of this in one file? I don't feel like I want to do that. Let's I'm gonna break this up because I want this to be maximally readable. So yeah, I'm gonna do that. I'm gonna do that now. I'd rather do it now than later. So simple um, linked list. Yeah. We'll keep the lowercase. Okay. And link. Um, what did this break? Oh, it might just be the yeah, that was fine. No packages found for what? Wait, let's run this real quick. Linked list test line 36. Oh, there you go. Okay. I don't think I understand. what this is complaining about. Come on, Claude, save me, please. Come on, Cloud. Oh, I think I know what the issue is. So I have um here. Oh, wait. No, that's not it. No, that's not it. Did I mess up the name? Simple linked list test. Um, no packages found. What? Um, yes, it matches. Okay, we'll try that. Need the cache. Oh, okay, that worked. Apparently. Oh wait, no, it didn't. It came back. Um, oh man. Okay, so we're gonna take this here. We're gonna make a new one. I'm gonna come back to this. Is not gonna break anything right now, and I don't want to spend time doing that right now. So let's just check this. Um, and let's go ahead and commit. Okay. What? This is gonna just annoy me so much. Um, I'm just gonna take a screenshot of this and put this in Cloud A, and this here as well. Maybe there's something I'm not doing right. Okay. We need to do a tidy. Nope, that didn't work. I said I was gonna said I was gonna like move on, and I have not. I am fixated. I guess it doesn't like the naming convention. That is interesting. I guess it doesn't like that naming convention. Um, yeah, I don't know why. Hmm. Okay, so it does. So yeah. So camel case is preferred for file names is the convention, and the compiler, I guess, is trying to enforce that, or at least give me a warning. So that message was not helpful. Um, okay, so we're just gonna stick with this camel case. Ah, okay. Uh, the stress is killing me. Still don't like that either. That's so weird. That is so annoying. I've spent too much time on this. Okay, so we're just gonna keep it like this, I guess. Um, One thing that might be getting in the way too is that Mac computers are agnostic in terms of the capitalization, whereas PCs are I mean sorry, Mac PCs do not distinguish the capitalization in file names, whereas PCs do. So sometimes you have to change the name to something unrelated and then change it back. Um, and I can try that here, I guess. Okay, so now that works. And if I go back and I change this to something unrelated, and then I change this here to nope. Okay, I'm just gonna leave it all lowercase for now. Yeah, this is really annoying. I don't like the way that this is working out, the file name thing. So now this one is broken. Okay, well, whatever it is, we gonna just leave it like this. This is fine. Um, let's just go ahead and do a commit. But my bagel went fast. Ooh, I haven't had like an actual lunch either. It's fine. Okay, so we got that. Um, we can make a new file now to put our. We're gonna move our test to a new file for just for testing the doubly linked list. Um, and we're gonna make a new file as well for the doubly linked list. So we're gonna take this and we're gonna put package linked list. We need that. We also need to take this here. Oh, I put it in the wrong file. My bad. Let's go here. Okay, so we can do the doubly linked list now. So we need a new type for doubly node struct, and this will have value, which can be anything. Whoops, curly brace. And this will have next, which will be a reference pointer to a doubly node, and we can have previous, which will also be a pointer to a doubly node. And then we'll have a new struct for the linked list itself. And there'll be a struct. And this will have a field for the head, which will be a pointer to doubly node, and tail, which will also be a pointer to a doubly node. This will return a pointer to a doubly linked list, and will return the address. We'll instantiate a new empty. We'll make a new empty um, struct with nil values, like that. Okay, so now we have to be able to insert. This is going to be a method on doubly linked list. And it's going to be called insert. And this will take in a value, which will be an interface. So when we do an insert, we say new node is the address of a doubly linked list, or doubly node. Um, this is just making a new node, and we're going to just give it a starting value of whatever the incoming value is. Okay. The music was getting kind of choppy. Um, Um, okay, I'm gonna take a little bit of a break here. I just realized something I want to do to make this experience a little better for you all. So I'm gonna make a quick adjustment to how my stream is showing up with the chat and stuff, and then I'll be back. So give me like 10 minutes. We've already been doing this for about 40 minutes anyway, so I do need a break. So don't go too far, but if you do, definitely come back and I'll see you right here. Yo, what's up? I'm back. A little faster than I thought I was gonna be. Um, for some odd reason though, my music isn't capturing. I think I might have done something. I really don't know. Um, I'll have to just figure it out later on. Okay. So, anyways, we're gonna get back into this. We're not gonna fiddle around with this too much. Big face, boom, there you go. Um, okay, so we were in this, and the goal now is to just continue working on this doubly linked list. Um, and I have the test created. I made a separate file for this. We have the insert started, and we can go ahead and finish this insert statement here. Or this insert method here. So we made a new node, and now we need to place the new node in the data structure. So if the head is nil, then we want to take the head and make it equal to the new node. And also for the first time around, the new node will also be the tail as well, because there's only one thing at that point. However, if it is not, if the head is not nil, then we'll say the new node dot next. So in the new node, we'll say that its next thing is going to point to the head, and we'll say that the head, the whatever the hmm, okay, so the new node next will point to head, the head, old head, previous will point to new node, or will be assigned to new node, and then the head will become the new node. So this, so basically, this will effectively make it where the new node is the is at the beginning of the list, and the old is shifted one place back. Hmm. So we're copying over data, and then we're moving over a copy of the data to the new node. No, no, no. We're dealing with addresses here. We're taking the address of the head, or the reference rather, the pointer of the head, and we're making it the new node's next. And we're saying, hey, head, uh, whatever that head was, and we're saying, hey, your whatever you were pointing to in the past or your previous thing, which will be nil if it hasn't. add one before, it'll be set to the new node. We should probably draw a diagram of this to make this a little easier. Let's use freeform and let's make a new one here. Call this doubly linked list insert. Okay, so we have a node, and a node has a value. Let's make this text separate. Value, and let's make this a little bit bigger. Okay, so new node has a value. Let's also put a name on this as well. And the node also has a next and a previous. Okay, so at the beginning, when we do first insert, um, it's going to be like this basically. First insert, the node is going to have next, and next will point to, it will be nil. Wait. Yeah, it will be nil. I don't know why I said null earlier. So it'll be nil, and we'll say that this is going to point, the value of this next will be nil. Okay, that'll be nil. Okay, so this is the first iteration of doing an insert with this doubly linked list. Okay, so then next we have the, so we'll call this node, call this N1. It's too big before. And we'll make this 36 or 36, yeah. Okay, so this is N1 here, and we should make this a special color. How about blue? Okay, so now we do the second insert. Here. And in the second insert, we're going to be adding into. Okay. So N1, uh, actually, yeah. So this will still, this previous for N1. Oh, we got these backwards. We got these backwards. So it should be like, oh, I could have just kept it. Okay, so this is N1 here, and this is going to be N2. We'll just do it like that. So N N2 or N1 is still going to have a next of nil, but the previous will change to N2, and it'll be a pointer. to N2. And then N2's next is going to be a pointer to N1. Okay, and then N2 will not have a previous. So then I'm only going to do the third up to the third insert. I think that will get my point across. Okay, so then the third insert, whoops, third insert right here will be another one of these here. This will be N3. N2 will point to I have a pointer N3. This will now point to N2. And yeah, so that's how that goes, like that. Okay, so let's put like a little box to sort of make this a little easier to see. Let's make this red, or make this magenta. Okay, so this is the new thing that was added right here. And then this is the new thing that was added right here. Okay, so that's what we're doing basically. We're making the new thing, and then we're pointing to it and pointing away from it. And the new thing is always going to have a nil um, for it's always going to have nil for the previous until it gets something to point to. Okay. Okay. Um, mhm. I wonder how I messed up my sound, by the way. I have no clue. No clue how to fix that midstream, to be honest. I wonder if I do that. Nope, that didn't fix it. I feel like I'm gonna have to restart OBS, and I don't know if you can do that during a stream and it not break something. I noticed that OBS is very buggy sometimes. Okay, so um, let's go ahead and give this a title so we can just pop this into our images as well. So we'll just say it's called insertion algorithm for doubly linked lists. Oh, that is too big. Create. Put that right here. And then we'll just make these gray so they don't stand out quite as much. Okay. And then we'll just take a screenshot and pop this into our repo. I think we should make a small change to this. In fact, we need to delineate the fact that there's a head and there's a tail here and make that really obvious in the graphic as well, since that's a significant part of this data structure. So let's just adjust this here and we'll just add some text here. We'll say the first time this happens, the the only thing is both the head and the tails. Let's make this pink or green. Make this green. So that. So this becomes a new head, and this becomes a new tail, and then this becomes a new head, and this stays the tail. Um, oops. Yeah. I think that's about right. Let me make these green so they match. Okay. We make the backgrounds of these some other color. I get way too into this part of things. Not gonna lie, making the little informational graphics is my one of my favorite parts of all this. Okay, so let me just double check this with the code I've written here by reading through this code manually. That will help me a lot. Um, okay. Okay, so why is that complaining? Oh, we need package. Forgot to do that. Okay, so the first time the head is, or the thing is inserted, the head is the new node, and the tail is also the new node as well. Ooh, excuse me, burped. Okay, so it's the head and the tail. Okay. Here we can just put that in the same thing. There you go. Okay. So the second insert is going to skip this block of code here, and it's going to go to the else condition. Going to go to the else condition, and in that else condition, um, what's going to happen is it's going to take this new node dot next, which is this one here. So the green stands for new node. Let's go ahead and put some text there as well. We'll make this um, purple. I'll make this purple as well. There you go. So new node is purple and italics. So this is the new node, and so is this one. So when it does that, when it adds a new node, and there's already a head, then we'll say the new node dot next. points to the head or to the previous head, which is this one. And then and the previous heads dot pre the previous heads and the old heads previous points to the new node here. And then lastly, we say the head is now the new node. And then the same thing happens here. We'll take the new node and we'll say its dot next is pointing to the old head, which is this one. And then we'll say the old head's previous points to the new node, and then the new node becomes the head, the current head. Okay. So it's going to grow like this. Well, really, it's going to grow like the wrong way. Camera's reversed. It's going to grow like this. It's going to go this way, like this. Okay. Okay. So we can go back and uh, just update this graphic in the repo as well. Let me make this text just a little bit bigger. Actually, no, this is fine. This is fine here. I'll also put a clip of the code in here as well. I think that'll be a good reference. Possible nil. Um, that wasn't showing up before. Oh, it's because is there something wrong with my doubly linked list? Um, let's take this to Cloud and see what Cloud has to say. Let's see what it has to say. If you do Command Shift 3 to take a screenshot of your whole screen, by the way, you can just pop that screenshot into Claude, and you don't have to worry about pasting code in. It's just faster, but you'll end up with a bunch of screenshots on your desktop. But to me, I don't care. I'll just delete them later on. So it's saying it's possible that list could be nil itself. I don't think so because this will always return an empty struct of the type doubly linked list. Okay, so we can just, I guess, add a test here. If list is nil, then we'll just we need to do a fatal or t dot fatal. We'll say doubly linked list should not be nil. Sure. Okay. Um, wait. Oh, we need to do panic. Or I'm not sure what difference is here. Um, see, this wasn't showing up as an issue in my singly. Oh, now it is. This wasn't showing up as a warning yesterday. I promise you it wasn't. I don't know why it is today. Let me just give it my implementation code, I guess. I really didn't want to get into this, but this is something I don't understand. So, okay, so this function always returns a pointer to a new doubly linked list struct and will never return nil, which is good. It is a false positive. Um, so this should be fatal. Is that what it wanted me to do? Okay. I must have overlooked that. I promise you, I did not see those yellow squiggles yesterday. Because I do not like to keep warnings in my code. It irks me. Okay, so I think we're good with that. This is helpful. Okay, so we got the doubly linked list. We got the insert here, and we can take our graphic that we made in freeform, and we can take a screenshot of this insert code, where the new node is at the beginning of the list. Is is the head. Shift to one place back. Okay, so we can just take this here. I'm going to put this code excerpt in my actual document because then it'll be nice for people to see both in the same place as such. Okay. Okay, so we can just take this and then do. People love this kind of thing because it's so helpful. It is super helpful. Um, when you're trying to remember something you've learned, it's super helpful for you to be the person that makes the explanatory graphic or whatever. It's going to challenge your understanding. In fact, let's take a little bit of a break to talk about this. Okay, so I want to talk about something that's really important. Oh, wait. I know what we should do. We should go back to the screen and make this into like a little YouTube clip. So we're gonna do it like this. Hey y'all, this is Key, and I want to show you something really quick that I think will be really helpful for anybody who is trying to learn new coding concepts like design patterns or algorithms. This is a thing that I do that I find super helpful, especially when you're learning a lot of stuff that's hard to remember. So here's what you can do. Firstly, when you write your code, it's really important to write comments that explain what it does. Now, this may not always be the way you do it when it comes to production quality code, but when it comes to you doing code for yourself, this practice here is going to challenge your understanding of what's going on, right? So if you read through this line by line and you can accurately describe what's happening, then you're in a good place. Something you can also do is take the entirety of this code's comment after you've written it, and you can go and use something like Claude or ChatGPT, and you can say something like, please check that my comments are accurate in the following, right? So you can use this to validate that your plain language comments are accurate. And I find that it will oftentimes give you like hints and tell you things about the code that you might not completely understand, and that's great, right? Because you're going to get that understanding from this. Then you're going to go back to your code. You're going to update and adjust these comments to be accurate. Okay, so do this manually. Do this for yourself first, and then use your preferred AI tool to verify your understanding is correct. Okay. AI is not perfect, but it is no worse than a human being when it comes to this. It's better than a human being, I would say, but it's still not perfect. Okay, so that's the first thing you can do. The second thing you can do is you can use Freeform or Miro or Excalidraw and make an explanatory graphic. Now, what this explanatory graphic is going to do when you're the one making it is it's going to allow you to further ensure your understanding, and converting something into an image that is otherwise very abstract in your mind is also going to solidify it in your memory a lot better. And what's really valuable about this is maybe one day in the future, you're going to be preparing for an interview, or you're going to be trying to, just remember something that you learned a long time ago that was really, really complicated. Well, this graphic here is going to allow you to recall things a lot easier, okay? A lot more easily. And these types of things help a lot when other people make them and you can see them, but when you're the one that does it, it's really going to seal the deal in your memory. Okay, so I just wanted to share that with you. These are things that I do all the time, and I find them super helpful. And if you can describe something in plain language, then you probably understand it. If you can draw a picture or create a diagram of something as well, you probably also understand it too. Okay, so leave yourself breadcrumbs so you can always trace back to what you've learned in the past. And when you do this frequently and often enough, then you'll end up with a nice little library of things that you can use to quickly study to prepare for those coding exams, those coding interviews, and whatnot. Okay. So, thanks for being a part of the Wolf Pack. By the way, if you want to see more videos like this, all you have to do is go check out the survey that I have. Look at the description down below. I have a survey where I'm asking questions about the kind of content you want to see, and I can make more things like this, and I can even share these things with you in the future. Okay, so do my survey, help a brother out, because I want to do good for you as well. Okay, so thanks so much. Peace. Okay, we'll see that's how you do it right there. I figured out how you can record a video in the middle of a stream, and it's just built into OBS. And that's my little clip. Okay, so we finished this. We updated the graphic here, and um, we are sitting at a good hour. Hey, what's up, Manpreet? How's it going? Thanks for coming by. I appreciate your presence. Thanks for coming by. Feel free to ask a question. We're talking about linked lists. We're making linked lists. We just made a doubly linked list and we added an insert to it. And I think we're ready to move on to the next part of this little project here. Okay, so let's make sure the tests are good here. We got to write a test for the insert. So we'll do that right here. Test insert, doubly linked list insert e testing. Oops. Pointers are getting better. Coming from JavaScript, I just feel like I was just babied so much. Where I never had to think about certain things like memory addresses and pointers and stuff. And I'm glad I learned a programming language before I got to this. That didn't include it, because it's making it easy because I don't have to learn as many things. But pointers and whatnot, that is quite a bit. It's quite a different way of thinking as well, because you kind of have to start to know about like the way things are being stored in memory for it to truly make sense. Okay, so we're going to take this doubly linked list. We're going to insert a new value of one in a new node. Insert a value of one in a new node. This should be the head. Okay, so we'll do if list dot head is nil, then t dot error after insert head should not be nil. I looked it up earlier too, by the way. Nil is the zero type of a pointer. So that's why we're concerned with nil. Okay, if the tail is nil, so we want to do the same test here for the tail, because remember the first time we make an insert into an empty doubly linked list, the node is going to be both a head and a tail until we start to add more things. Okay, so now we are going to check the value. So if it's not one, or list dot head dot, oh, I'm sorry, this should be tail. Tail dot value is not equal to one. So if either of those are not one, then we'll say t dot error, and we'll just insert here expected head and tail to be value, oh, value to be one dot head, and we'll just interpolate b tail um, v, and then we'll say list dot head dot value and list dot tail dot value. Okay, cool beans. Let's go ahead and run the test just with that and see what we get. Okay, so that passes. I'm gonna make the test fail just to make sure. Okay, so cool. Always make your test fail because in that way you don't get false positives. And then you're gonna look crazy if you do that. You don't want to look crazy. Okay, those false positives are very tricky. Okay, so yeah. Okay, so now we can go to the next thing here, which is we need to do another insert. And then this insert here is just going to be for value two. And then we're going to just do the same check here. We're going to do this for the head value should now be two, and the tail value should be one. And then we can change this expected head value to be two and tail value to be one. Got head, got tail, heads and tails. Okay, so that's good. And then lastly, we need to check that the previous and next pointers are accurate. So if list dot head dot next, the head should be pointing to the head should not the head's next should be not be pointing to the tail, basically. It should be pointing to. Oh wait. It should be. It should. So the next head should be pointing to the tail when we do our. Oops, let me quit this. Yeah. So the next should be pointing to the tail when we do our second insert. That's correct. So um, list dot tail. So if it's not that, or if list dot tail dot previous um, is not list dot head, then so let's write a comment here. If the current head doesn't point to the does the current heads next. Okay, so if that happens, then we'll just say t dot error links between nodes are not correct. And we can close this for now and just run our test again. And we got a pass. So I think we're good on that. And yep, we got our implementation, we got our test. And the next thing we need to do is we need to go to this visualizer that we created. So this visualizer right now, it works. The visualizer right now will work with the simple linked list, but we need to adapt it, or we need to make a new one rather, that is going to be for the doubly linked list. So I'm gonna just make a quick change to the file name here. Our single or simple linked list visualizer. Ah, that is such a big name, but it's fine. And then simple linked list visualizer. Because we're gonna have to I'm gonna make a new file basically so that these are all separated out because I don't want to have these giant files and all this complicated stuff going on. Um, so I'm gonna take a break for like 15. I'm gonna come back and we're gonna do probably like another 45 minutes and then the stream's gonna be done, okay? So don't go anywhere, but if you do, please come back. You know where to be, right here on Primitive. See ya. Oh, I fixed the audio by the way. Okay, I'm gone for real now. I'll be back. Hey, so I am back after a short little break. Now tell me why I took my dog out to walk. And I left his harness on him because I knew he was only going to be in his crate, just for this stream. And when I got to go get my dog, he had basically succeeded in chewing through part of his harness and destroyed it, basically. So it is in the trash. Luckily, I have a backup harness. Um, but yeah, the harness that he chewed through was like $50. And like every time I see him do it, I'd be like, don't do that or whatever. But there's only so much you can do, especially if you're not watching them every single moment. So it is what it is. It's a dog. It happens. But yeah, that was $50. It's so expensive. I'm gonna have to go on Temu or something and get some harnesses from Temu or something like that. Okay, so let's get back into this. I'm gonna be streaming for, let's say, another 40 minutes. So at 2:30 p.m. Central Standard Time, I'm going to go ahead and get off of here. But I'll be back on later, probably either tonight or tomorrow for another stream. So, we're on the grind. We're doing this. We're trying to get ourselves together, okay? Hopefully you got something that you're working on. You can study, if not GoLang. Okay, so where we left off is we need to make the visualizer for the doubly linked list. And we have these god-awful named files. I'm gonna make two more. So doubly linked list visualizer.go and what if I do this? Doubly. What if I do that naming convention? I kind of like that. Um, I kind of like that. Doubly. Maybe we don't have to do this part here. Yeah, I kind of like that. That's a little easier to read. Okay, cool. I'm gonna do this one too. Got a little typo here. Yeah, I like that. Let's do this one up here too. Yeah, that's nicer. Get rid of those long names. Nobody wants to read a long name. Jeez. Okay. So .visualizer.go. I kind of like that. Okay, so we need to make a new visualizer. At the end of all of this, we're going to have a factory basically that's going to do all of this for us, but we need to make all the individual pieces of that factory first. So there's gonna be like a layer of abstraction at the end of this whole project. Um, yeah, it's gonna be called Visualizer Factory, and it's gonna go in our main application. Okay, let's start with the test here. So um, import testing. We don't need this anymore. This is also for package. Okay, so let me make a test. This is for the test doubly linked list visualizer. Okay. What does this test need to do? So we need to make a new visualizer or new doubly linked list. Then we need to insert, let's just say three nodes, and then we need to make new visualizer, capture result of visualizer for the list, and then we need to check that result is plain as expected. And then our expected is going to be very similar to what we did for the simple linked list, and it is just going to be a string where it's nil on one side and nil on the other side, and then we'll have these bidirectional arrows going from 3 to, and then 1. And by the way, I'm going to have to go back to freeform as well. And I'm going to need to update this because this is accurate, but I've been doing mine kind of in the reverse order. This really should be flipped. Everything should be flipped horizontally so that the head is over here. So this is correct. It's just backwards. So I can do that at the end. I'll come back and fix this up. Okay. I'm prone to that. This is how I imagine it in my head, but it's fine. Okay, so if result is not equal to expected, of course, we'll just say you got error f expected, but got okay. We don't have a result yet. So first we got to do is make a new doubly linked list. Okay, and list.insert 1, list.insert 2, and list.insert, we'll do 3. So that's this part right here. I got to use my keyboard instead of my mouse. I use the end home key to go to the beginning of the line and the end of the line. Okay, so make a new visualizer. Visualizer is new doubly linked list visualizer, which is going to be a function that returns a pointer to a new visualizer, and then the result's going to come from that because we're going to have a method on it. Visualize, and we're going to give it our list. So we can move this line up here, and we'll go home to go to the beginning and then change that capital C. Let's just go ahead and fix our comments. So this is the complete test here. How do I change tabs? How do you change tabs in VS Code with just the keyboard? Control Option. Oh, okay, there we go. So Control Option arrows is how you change your tabs. Okay, so now we're gonna make the visualizer for the doubly linked list, and we'll make a new type, doubly linked list visualizer, like that. Struct. Oops. And then we're making a new function that will return a pointer to a new doubly linked list. Struct, an empty struct. We're going to return the address, the doubly linked list visualizer struct. So it's going to initialize it. Empty one. And then we're going to make a method for this doubly linked list visualizer. This method will return a result string by taking the values of the doubly linked list, or actually it will let's break this down. So it will traverse the doubly linked list, and it will traverse starting at the head until towards until reaching a null pointer for next. So this will effectively start at the yeah. So this will effectively start at the whatever the most recent value is that has been added to the linked list. So I'm gonna keep going until it reaches the nil pointer for next. And it will append each to a result string, result slice of strings, which will be joined and returned at the end. So func, and this will be a method on doubly linked list visualizer. And it'll take in a list, which will be linked list dot doubly linked list, and this will return a string Okay, so the first thing we're gonna do is we're gonna have a result, which is gonna be a slice of string. And then we're gonna have, for this result, the first thing we're gonna do is put nil at the beginning. And then we'll say current. We're making a variable called current, which is gonna be keeping track as we loop through. So it's gonna start at the list.head. And then we're going to do a loop over lists by going next to next. So for current, while it is not nil, we will take the result. And why is this complaining? Oh, it's not returning yet. Okay. So it'll take the results and it will append to the result a new string, which will be the value. Okay, after it does that, the current will be replaced by whatever is next to the current. Okay, so at the end of this, all this, you'll say the result needs to be finalized by appending nil, and then we need to return a string. I can do shift, oops, shift square brackets is how you tab in a whole line in either direction. So string dot join, take the result, and we'll put space here. And this is going to be the delimiter that is going to go in between all of the different strings in the slice, basically. And we need to go ahead and bring in this import as well. Okay, so that oh, we need to make a new linked list inner visualizer. Oh, so we have a linked list visualizer. We have an interface that we were already using somewhere. Did we have one? I thought we had an interface for a linked list. I don't think I need one. Yeah, let's make an interface that all of these will have in common, and then we can just add the visualizer or the visualize method to it, and we'll have a visualize method for each of these structs. Visualizer go. And this will help us achieve this factory pattern that we're after. We don't need this right now, but we will need it later on, I guess. Um, 1 second. We need to have. I think we can use the same interface. I'm just checking here on my other screen. Yeah, we can use the same one. Um, for both. Um, well, hopefully we can. I don't know. Okay, our test passed, so that's good. Um, so what I need to do is I want to see the result in my console just for kicks and giggles. Um, so let's go ahead and do that here. And there we go. So that's it right there. Okay, cool beans. Um, Let me, I'm a little bit off the rails here. So we have a separate file for each concrete visualizer. And it's okay because they both have the visualize method, but their own version of it. And each of these have the same interface, which is to take in a list and this should be a list of should be a list of nodes. Oh, well, the list is going to be different for either one. It's going to be a list of doubly linked list or a. Okay, that's the thing. It's like the lists are not the same. Okay, so yeah, we have to use this. There's probably a better way to do this, but I'm just going to stick with this right now. Um, and then maybe come back to that part later on. Um, okay, so I think we succeeded in this as far as I'm concerned. Let's go ahead and do a commit. And we'll just say that we did a bunch of stuff. I should have done some more commits, but it's fine. We'll just say commit added visualizer for doubly linked list, created common interface for visualizers, and separated files for code and linked in packages. Okay. Ooh, lottie, lottie, lottie. We got that done. Okay. Um, so one more thing before we go. We still have a little bit of time. I have like uh I have 22 minutes. I want to get ahead of this and oh, I didn't even okay, I did. I want to get ahead of this and the next thing I'm gonna have to do is I'm gonna have to extend all of this and add a new visualizer and a new type of linked list. It's going to be a circular linked list. I've never done that before. So um, I'm going to say, please explain to me in plain language in the form of an article how a linked or how a circular linked list works, what it is, and its main characteristics. And then we'll have Speechify read it for you, read it for us. Okay.
Understanding circular linked lists, the never-ending data structure. Imagine a group of friends playing a game where they pass the ball around in a circle. Each friend only knows who they're passing the ball to next, but the last person passes it back to the first, creating an endless loop. This is essentially how a circular linked list works in computer science. What is a circular linked list? A circular linked list is a variation of a linked list, a fundamental data structure in programming. In a regular linked list, each element called a node contains data and a pointer to the next node in the sequence. The last node typically points to null, indicating the end of the list. However, in a circular linked list, that last node instead points back to the first node, creating a closed loop. This seemingly small change leads to some interesting properties and use cases. Key characteristics of circular linked lists: no true beginning or end. Unlike a standard linked list, a circular list has no clear start or end point. You can begin traversing the list from any node and eventually return to where you started. Continuous traversal. You can keep moving through the list indefinitely without reaching a null pointer. This makes circular lists great for applications that need continuous cycling through data. efficient insertion and deletion. Adding or removing elements can be done efficiently, especially if you maintain a pointer to the last node. This allows for O1 insertion at both the beginning and end of the list. Memory efficiency. Circular lists can be more memory efficient in certain scenarios because they don't need to store a null pointer at the end. Potential for infinite loops if not handled carefully. Algorithms working with circular lists can easily fall into infinite loops. Proper termination conditions are crucial. How does it work? Let's break down the basic operations. Insertion. When adding a new node, you adjust pointers to maintain the circular structure. For example, to add at the end, new node points to the current first node. Current last node points to the new node. Update the last pointer to the new node. Deletion. Removing a node involves adjusting pointers to bridge the gap. Locate the node to be deleted and its predecessor. Update the predecessor to point to the deleted nodes next. If deleting the last node, update the last pointer. Traversal. To traverse the list, you start at any node and keep moving to the next until you reach your starting point again. Real-world applications. Circular linked lists find use in various scenarios. Round-robin scheduling in operating systems. Implementing undo functionality in applications. Managing turn-based games. Representing repeating structures like calendars or playlists on loop. Conclusion. Circular linked lists offer a unique twist on the classic linked list structure. Their circular nature provides both advantages and challenges, making them a fascinating and useful tool in a programmer's toolkit. Whether you're managing a carousel of images or implementing a sophisticated scheduling algorithm, understanding circular linked lists can open up new possibilities in your programming endeavors.
Okay, so let's see what a struct looks like. Maybe we can make a little freeform graphic for this. So we're going to do this as a unidirectional node. Um, Let me just check my notes and see if that's what I was going to do. Um, so we already have this node for the simple linked list, and we'll just reuse it. Um, yeah, we're going to reuse this one. I guess the difference here is that at the end of the linked list, the node will point to the head. So it can basically become a circle. Okay. Um, I don't know. I guess to me a bidirectional one would make sense, but I'm sure there's a. Let's just check. Is there a linked, doubly linked circular linked list? Doubly circular linked list. I don't know. I'm just making up words here. I really don't know. Yes, there is a doubly circular linked. Okay, so we're doing a singular circular linked list technically. Okay, cool. Let's make a new graphic. Make this 64. So we'll call this single circular linked list. We'll make this bold because I'm bold. And then we're going to make this where each node represented by a little square, and each node is going to have a next, and it's also going to have a value. Okay. So these will be arranged in a circle, of course. Let's just do 3 of them. And we'll have a start. Do we need to keep track of the start? No, we don't. But we'll be able to keep track of the head. The head is the start, I guess. Okay, so this is going to be the head over here. And we're going to take this and we're going to put this into Claude to make sure this is correct at the end. But I want to make sure that I'm doing this on my understanding. So let's make this a little smaller, 24. Get our music going again. Okay, so this is a single direction. This is going to be the tail. Let's make these 30. So this next is going to point to, there you go. So this will be, oops, this will be N1, node 1. This will be node 2. And then this will be node 3. And this next, this go here. I want this to be a curved line. How do I make this curved? Is there a different? I need this. We need to put an arrow at the end and make this red. Oops. No. No. There you go. And this is going to go this next all the way over here. And this one's going to go from this to up here. I have my Pokemon Go Pokeball in my pocket, so it's like vibrating every so many seconds. But you know what? That's the sacrifice you make to get a 2-for-1 special in life. And I am definitely maximizing my productivity right now by catching Pokemon while I do the stream. Don't judge me. Okay, so this is our single direction. We're gonna make it's one direction, like the boy band, I guess. Um, we're gonna make this here. Ooh, we make that gray. Maybe we need to make this gray a little darker. Mm, too dark. And we can make this white. Okay. Um, so I think this is what we're aiming for here. We'll just take a screenshot and we'll just say here, is this graphic correct? Let's see what it says. It could be wrong. Oh, so we don't have a tail reference. Oh, there's no tail, I guess. Okay, sure, why not? I'm gonna clean up my desktop in a little bit here too. There you go. Um, create a simple written description for me. I'm gonna take that description, I'm gonna plop it in here, and then we're gonna be done. And I'm gonna put this in the repo as well, so that anyone who wants to have this will be able to see this and use it. Get out of the way, Speechify. We're just gonna literally just do this, make it easy on ourselves, and just go like this. Um, let's group these together. Uh, group and put these here and put our explanation here. We can make these texts larger, like 24. And then we'll put this right here like this. Okay, so I think this is good. You always want to double check. Never not double check. Because AI will have you out here looking crazy if you do not double check. Okay. Single circular linked list is a data structure where each element contains two parts, a value and a pointer to the next node. Okay. The last node's pointer connects back to the first node, forming a circle. There's typically a head pointer that points to any node in the list, often the first one. There's no true head in a circular linked list, by the way. You can traverse the entire list by starting any node and following the pointer until you return to the starting point. There's no end to the list in the traditional sense, as it forms a continuous loop. Adding or removing elements involves adjusting the pointers to maintain the circular structure. Okay, so this would be good for continuously cycling through data. Okay, cool. Let's go ahead and make this screenshot a part of our code base. We're just gonna paste it in here. We'll call this single circular linked list. I used to dread linked lists. I don't know why, but I used to have a simultaneous dread of it and also a fascination with it because of, it just made me feel like very hardcore the times I did study it. Now it's not as intimidating. It's hard to code it. It's hard to code and to do all the algorithms on it, but like understanding why those algorithms work, like that's not as hard anymore. And I'm glad that that relationship has changed because it used to just bring me a lot of anxiety. But I feel better now. Okay, so we are coming up against 2.5 hours, which means our stream is basically winding down here, I'm going to do a last commit to add this image. So add explanatory graphic for a single circular linked list. Okay, so we did that, and I think we are good to go. Um, I'll likely be on here later on tonight because I need to keep up my little pattern here, right? So I'll be on either tonight or tomorrow. Just go ahead and subscribe, and if you want to know when I'm going to do my streams, if you subscribe and check out my channel or hit the notification bell, then you'll get a notification whenever I set up a new stream. Okay, so I usually set them up about an hour or an hour and a half before I actually do them, so you have plenty of time to go get some snacks, to set up your own project if you want to work on something, and all of that. And also, don't forget to check back on my channel later on. Earlier in this stream, I recorded an explanation for um, what did I do? I recorded an explanation of how to use these graphics as a way to study. So if you're interested in that, let me know because I can go more into depth. But just check my channel and you're going to see that there's a new video up, like a regular video, and then you can check that out. And maybe I'll make that like my intro video or something like a feature video on my front page. So, anyways, thanks for coming by. Thanks for checking this out. If you're watching this from the future, thank you for doing that as well. And uh, don't go too far, but if you do, definitely come back and I'll catch you later. My name is Key. This is Primitive. Adios.